Assalamualaikum. My name is Amirul Fazli. So today I want to discuss about physics-related need or concept and relevant physics principle involved. So electric fans satisfy the need for thermal comfort by generating continuous airflow. The core concept is converting electrical energy into mechanical energy. So this airflow accelerates switch evaporation and heat transfer from the skin rod cause convection, creating a cooling sensation. So when electrical current flows through the motor's wire coil inside a magnetic field, a magnetic force is generated. Based on Fleming's left-hand rule, this force creates a torque that spins the motor shaft, converting electrical energies into kinetic energy. In induction motors, alternating current in the stator creates a rotating magnetic field. According to Faraday's law and Lenz's law, this changing field induces the current in the rotor, forcing it to spin and follow the magnetic field. So fan blades are designed with a specific curvature and angle of attack. As they rotate, they create a pressure differential between the front and the back of the blades. So the high pressure zone pushes the air forward, creating a steady breeze. And the generation of airflow relies on the action and reaction. So as the fan blades push air molecules forward, the air molecule exert an equal and opposite force back onto the blades.
Assalamualaikum warahmatullahi wabarakatuh. A very good morning to everyone. Today, I will explain how rotational motion works in a ceiling fans and its relationship with electrical energy. A ceiling fan is a good example of rotational motion because its blades rotate around a fixed axis at the center of the fan. When the fan is switched on, electrical energy is supplied to the electric motor. The motor then converts the electrical energy into mechanical energy, causing the blades to rotate. As the blade spins, they move in a circular path and push air downward, creating airflow throughout the room. This airflow helps to cool the room and improve ventilation. The faster the blades rotate, the stronger the airflow produced. In conclusion, the ceiling fans demonstrate rotational motion by converting electrical energy into mechanical energy, which allows the blades to rotate and provide cooling.
Assalamualaikum, my name is Nur Rizman Zakwan. So I will show you how the system works based on the relevant physics principle. So we can see the formula, which is torque equal to I times alpha. The principle allows the system to convert applied force into rotational movement efficiently. So from the formula, we can see the exact principle is what allows our system to convert applied electrical and mechanical force into smooth, efficient rotational movement. So to make this easy to visualize, let's look at the diagram of an electric fan. When the motor housing exerts a turning effect, which we call torque, the fan blades begin to spin around the central axis of rotation, but the blades don't instantly jump to the top speed. They have to overcome the moment of inertia, which is essentially the physical resistance of the front fan's blade changing their rotational states. The heavier or longer the blades, the more torque the motor needs to supply. To keep our calculation and analysis clear for this chapter, we can use a symbol and variable you see in this chapter, which is the sigma used for the angular velocity. Angular velocity is the rate of rotation. Then we can see the alpha, which is we use it for the angular acceleration. Angular acceleration is the change in angular velocity over time. So I we use for the moment of inertia, which is the resistance of an object to change in its rotational motion. So finally we have a torque, which is the turning effect of a force.
So electric fans rely entirely on electrical motor to function. So this motor acts as the core system component that directly convert electrical energy into the mechanical energy that needed to spin the blades. So inside the motor, the stator contains copper coils that generates a magnetic field when plugged into the power source. So this magnetic field interacts with the rotor, creating a rotational force called torque. So this process is a direct application of electromagnetism. So specifically the Lorentz force, which forces the motor shaft to spin. The spinning shaft of the motor is physically connected to the fan's blades. As the motor rotates, it transfers its mechanical energy and angular momentum directly to the blades, overcoming their rotational inertia. This continuous rotation from the motor allows the blades to manipulate the surrounding air pressure and generate the steady breeze.
On this slide, I will explain the physical process, mechanisms, equation involved, and the outcome in a ceiling fan. When electrical energy is supplied to the fan motor, an electric current flows through the motor windings and create a magnetic field. The interaction between the electric current and the magnetic field produce a magnetic force, which can be represented by the equation F equal to BIL sin theta, where F is the magnetic force, B is the magnetic field strength, I is the electric current, L is the length of the conductor, and theta is the angle between the magnetic field and the current. This magnetic force generates torque, causing the rotor inside the motor to rotate. The rotational motion is then transferred to the blade, making them spin continuously. As the blades rotate, they push air downward and create airflow throughout the room. This airflow increases the rate of evaporation of sweat of our skin, make us feel cooler and more comfortable. Therefore, the main outcome of this process is the conversion of electrical energy into mechanical energy in the form of rotational motion, which produce airflow and provide a cooling effect.